If so, you'll get to see some of that data then. And then we also have this DPS, that stands for dielectric or density profiling system. So some of you may be familiar with the ground penetrating radar DPS technology. That one's been correlating well to asphalt density. So you may have heard of like the rolling density meter or something similar to that. So you guys have access to all of this data, but we'll be kind of just focusing on IC today. And go ahead and you can open up this first folder here. So inside each of these, we've got data, and we also have a PDF. So you can go ahead and open that first PDF. And each of these has a little bit of information about the project. And then if you scroll through, they have kind of step-by-step instructions on how to analyze the data in Veta. So best way to really learn Veta or, kind of understand this technology is to really just go through a lot of this data, use these example files we've given you and kind of go through everything. By the time you work through all 11 examples, I promise you will be a Veta expert. So if that's your goal, I do recommend kind of taking advantage of these example files we've sent. Obviously today we're limited on time, so we're not going to get to look at all of the examples, but I do recommend kind of coming through on your own time and taking a look at these. All right, so I'm going to close out of this. And now let's go ahead and open up Veta. So you may have a shortcut on your desktop, or you may have it pinned to your toolbar. If you can't find it, you can use the search tool and just type in Veta, and it should pop up. We're going to be working in Veta 8.0 today. So if anyone is having any issues actually locating Veta, please let me know. I'm actually going to open another window I had open here. All right, so I'm just going to give everyone a minute to open up Veta. And when you open Veta, you should just have a blank screen here that looks like this. And if anyone is unable to open Veta and get to this point, go ahead and just use the question box, and Subu or George will help you out. So to start out, we're just going to create a project using this new project button. So go ahead and click that. And the first thing that it's going to do is it's going to prompt you to save the project. So I'm just going to go and find the example folder that I have saved on my desktop, and I'm going to save my project there. So go navigate to wherever you have your example file saved. You can see I have my samples for workshop Veta 8.0.45 folder here. I'm going to open that up, and we're going to work out of the 5th example today. So go ahead and find the 5th folder in here. So it's 05 IC IN HMA. That is the naming convention of these is the technology, the state in which it was collected, and then whether it's for asphalt or soils. So this is an IC project in Indiana on asphalt. So go ahead and open that up. And all you're going to do now is just save the file name. So I'm just going to name it to match the folder. So I'm going to say 05 IC IN HMA. So go ahead and save that. And so now your screen should look a little bit different, and we have this tagline up here that just says the project does not contain data, use the add file button in toolbar. So all we've done is we've saved an empty project. So let's go ahead and add our intelligent compaction data. So you've got this add data button. And if you click on that, you're gonna have all these different options. So George just mentioned a lot about kind of data management and how you can get the data from the equipment into Veta. So a lot of vendors have some sort of like direct download option. So George showed some example of those. So depending on what vendor you're using, you may be able to just use the login credentials that you would normally use to access their software. You could actually just import that into Veta and bring it in directly from their cloud or storage server. So highly recommend. That's a super easy way of doing it. If you have that option, it's a great way to go. We're going to be using this option that says add data files. And so if you have data saved locally on your computer, or if you're using data that you have on like an external drive or a jump drive, you're always going to come here and use the add data files. So let's click on that. Now, because we saved our project in this folder, this 5th example folder, it's going to automatically navigate us there. If for some reason you saved your project somewhere else, you can go ahead and just take a minute, navigate to your example folder, open it up, open that 5th example file, and then you should just have one compressed file available of data. So let's talk about compressed files real quick. Obviously, if you're manually adding and storing IC data, what you may find is some of the files can be very large. So sometimes it's nice to compress those files into a folder. It just kind of shrinks the size a little bit. So Veta can read compressed folders, no problem. However, it will only read the first file within the folder. So what does that mean? It means you can compress individual IC files to minimize storage space, but don't compress, a bunch of folders together or a bunch of files together, because Veta will only read the first one. All right, so let's go ahead and click on that and then click open. And it's going to bring us to our add data dialog box. And so what you want to do here is you want to tell Veta what coordinate system and what unit your data was collected in. So this one, it's auto detected a coordinate system and location unit for us. But this is really important. Whatever your data collector on your roller is set to, that's what you want to input here. And if you ever have any questions about, well, how would I know what coordinate system it was? That's something that you would want to work with your equipment provider on. So Veta supports a ton of different coordinate systems. So UTM zone is just kind of a standard coordinate system. We've also got state plane in here. So depending on what state you're in, you'll have different state plane coordinate systems. We have some county systems for Oregon and Minnesota. So if you're in either of those states using a county coordinate system, you can use those. And we've also got some Australia and New Zealand coordinate systems. And then up top under miscellaneous, we've got this GRS 80 based. And that is just going to cover like a standard latitude, longitude coordinate system. So if you're just collecting in lat long, you'll use this GRS 80 based. But we're going to stick with UTM 16N because that was what our data was collected in. And we're going to stick with meters. So that's the other part of this is, if you're collecting in metric or feet or survey feet, you would just tell Veta which one it is. So once you get to this point and you've input your correct coordinate system and unit, you're going to click Add Files. And this little dialog box on the left is just going to pop up and let you know if there was any issues with the data. You can see that all of the data that was found was added successfully. You may have some data that has like a couple points that don't get added. So if you had a couple hundred points here that didn't get added, it's nothing really too concerning, but obviously what you're looking for is, you know, that there wasn't a large amount of data with errors in it. And then you should have a little map that pops up over here, which should show the vicinity of where you were working. And if you ever find that this little mini map does not reflect the location in which you were working, it's most likely because you've used the wrong coordinate system here. So if you end up, you know, with a bunch of data in the ocean or somewhere else, you may just want to double check your coordinate system and make sure that that's correct. So once you get here, go ahead and click OK. And so what you can see here is we've got some IC data that's been added to our map. So the viewing features of Veta are pretty much like any other sort of map tool. So you can kind of click and drag to pan around. If you're using an external mouse, you can scroll in and out using the scroll wheel on your mouse to zoom in and out. There's also some magnifying glass tools up here above the map. You can zoom in and out using those as well. So go ahead and just kind of zoom in and pan around and take a look at the data for a minute. I'm going to tell you guys about some other useful zooming tools as well. So I'm going to zoom all the way out here just using the scroll wheel of my mouse. And also above the map is this little dashed box. If you click on that, your cursor is going to change to crosshairs. And you can click and drag. Sorry about that. You can click and drag a little box. And it'll automatically zoom into that little box you just created. So that can be a really nice one, especially if you have, you know, several days worth of data or, you know, just a full day of production. That can be a nice tool to kind of zoom in on a certain area. Another nice one is up here above the legend. So if you find your legend that says pass count, there's a few tools above that. So one of them is this little picture that has some arrows coming off the corners. And if you hover over it, it says extent of data. And if you click that one, Veta is going to automatically zoom out and show you all of the data within the project. So that's a nice one as well. Just to kind of see, you know, the extent of all the data you have. And the other ones I want to show are these two arrow buttons right next to the extent of data button. So if you hover over them, you can see one says first location and one says last location. So I'm going to scroll in a little bit here. And then I'm going to click this first location button. And what it's going to do is it's going to take me to my data that has my earliest timestamp associated with it. So you can see here, kind of towards the beginning, it looks like maybe this is where they started for the day. Maybe the roller was parked here. Looks like they may have kind of like turned it on and off again or something, but then you can kind of see it kind of mobilizes up and then they start the project. So this is gonna be kind of the first timestamp. And then you can also use the last location button and it'll take you to the last one. So those are sort of, you know, some of the nice like navigating tools in terms of just zooming and viewing data. So let's talk about some of the other options up here above the map and above the legend. So one tool is this little ruler tool. So above the map, you have these two rulers kind of laying on each other. So if you click that one, this tool works very similar to like the path tool in Google Earth. So if you click and then click again, it's going to tell you a distance up here. And as you click, it's going to just keep updating and adding to that. And then you can click the ruler tool again, and it'll get rid of it. So this can be nice too, just to kind of get some ballpark dimensions. You know, you could kind of check what the approximate paving width was. So it looks like that's about 16 feet there, just under 16 feet. You could kind of just use that to measure some lengths and different things. So I'm going to click that to get out of it. We do have this back button here. So if you've zoomed in, you can always click this back button to take you back. And then let's move over to this map. So if you click on map, there's a whole bunch of different options under here. The first little section tells you or asks, you know, how you want to view your maps or how many maps you want to view. So I'm going to go ahead and click, you know, 2 horizontal maps. And then you can see that Veta's broken my maps into 2, and I can see my data on top and on the bottom. So this is really useful for viewing multiple data types at the same time. So if you come over and look at our legend, you can see that both of them right now say pass count. So we're really just looking at the same thing in 2 different maps. But if you click on this drop-down menu on your lower map or on one of the maps, you can see all of the data that's available under this project. So I can come down and I can click this CCV, and it'll change it. So now my top map, I'm showing pass count, and my bottom map is showing CCV. So what is CCV? George mentioned the accelerometer mounted on the vibratory drum. So each equipment vendor is going to have some sort of metric tied to, you know, the stiffness or something kind of like the stiffness of the material. They're all going to be calculated a little differently, and they're all going to be kind of called something a little different. So this one, I believe, is a Sakai roller. We can double check that in a minute, but, you know, Sakai maybe uses this CCV. Different vendors may call it something different, but it's basically that accelerometer measurement. Okay, we can also click that. We can look at roller settings. So this one, we have the frequency. We can come in and look at what the frequency was set to. You should also have, you know, the speed. This one, we don't have the roller speed. But you should normally have speed in here. You may have like the amplitude, temperature. We can look at our temperatures. So one thing with temperatures and asphalt in particular, which obviously, you know, if we were on a soils project, we wouldn't really care as much about the temperature. But for asphalt, one thing with temperature is right now you can see we've got these 2 options, and one says final coverage and one says individual passes. So what final coverage is just going to be the very final surface. So the very last thing that your roller fleet did to the project is going to show on final coverage. So for temperature, that might not be necessarily what we care the most about. So you can always click the button next to individual passes, and you can look at individual passes. So if I just check the box for pass 1, this is going to show me the temperature of that very first roller pass. So that can be really nice, you know, especially just knowing what that breakdown pass is right behind the screen. Like that can be a really valuable quality control tool. And then, you know, you can kind of just look, you know, at all your other passes and kind of see how your temperature may be cooling with passes and kind of different things like that. So you can kind of see, you could come in here and check any of those passes. All right. So I'm going to go ahead and just leave this on my pass 1 temperature and my pass count. And let's talk about legends. So you can see over here, we've got this legend that's showing, 8 different passes. And as I'm looking at my data, 8 passes here is this purple color. And I'm just sort of looking at my data. It doesn't look like I have anything, nearly that high. So it looks like for the most part, my data has a pass count of about 3. So you can see these kind of strips of blue in here. So what that's going to show is just where the roller drum is overlapping. So obviously, depending on our paving width and our roller drum, we're always going to have some area of overlap. So of course, those are going to show a higher pass count. But generally, it looks like the roller had about a pass count of 3 pretty consistently. Now you'll see there are areas where there was less. And that's obviously one of the great things about this tool and about using intelligent compaction is we want to be able to view consistency and make sure that whatever is required to get density is being done uniformly across the project. So you can just come in and see, areas where some roller passes may have been missed. Now, especially right up here where you've just got this area where there was only 1 pass. Things like that, you can, definitely is a good quality control tool to have, especially if you, had an area where maybe you took a core there or a density reading and it came out low. You can come in here and kind of look and say, oh yeah, well, I only had one pass in that area when I should have had 3. But, maybe we want to only view passes up to our optimum pass. We don't really care about, we don't really want to see all these areas of overlap. We really just kind of want to focus on, hey, did I get my 3 passes everywhere? I want to kind of clean up my legend a little bit. So to do that, we can come over into the legend box. So you just hover your cursor over inside the black legend box and right click and then hit customize. And that's going to bring up this legend dialog box. And these are really straightforward. You can just come in here and click any of these fields and delete them. And then you can also use this add button and it'll add a field. And then you can type in a value and use the drop-down menu to select a color. Lots and lots of colors to choose from, so you can really get creative with your legends here. You can kind of just see it's really straightforward. And as you're adding these, Veta will automatically sort them in order for you. So really what I want to do is I just want to make sure that my legend is only showing up to 3 passes. So I want to clean up my legend. I only want to show up to my target. So let's go ahead and delete passes 4 through 8. So I'm just going to click pass 8 and click delete. Delete. Oops, I accidentally deleted 1. So I'm going to change this to 1. So now note that my colors may look a little different from yours. I'll go ahead and change this back to red. So you should just have pass 1, 2, and 3. You can change the colors if you want to. And then let's click OK. So now you can see it's updated the legend and it's just showing me up to that pass that I really care about. So now it's a little bit easier to just come in and say, okay, I can zoom out and say, look, I had some areas here, here, where I was missing some passes, and those might be, ones to kind of focus on. And you can do the same thing for any legend. So you could come down here and customize your temperature legend. You can see that we actually had this temperatures look a little cold on this project for asphalt. So for pass 1 temperatures were, somewhere between 150 and 200, as high as 250. So you could come in here, right click in your temperature legend, click customize. And I'm going to add a value at 175. And I'm going to change it kind of to be in the same blue family. So now you can see I've added between 150 and 200, I've added this 175. I can click OK. And then that's going to update the legend a little more for me. So I can see, okay, I actually have, you know, more temperatures at 175, you know, so I just get a little bit more information by making my legend a little more detailed. So I did get a question in here that says, you know, where does this map come from? So that's a really good question. Veta uses Bing Maps. George, you can correct me if I'm wrong, but we use a Bing Map service. So the data that you bring in from your roller is going to include, you know, basically just like the coordinate and then your information, like your temperature, your pass count, all of that information. And so we bring in a map. It's a free map service. It's Bing Maps. So we bring that in and we just plot the data on that. So the map shown here is not specific to any vendor or any equipment. That's just going to be a free map service that Veta uses. And then I also got a question on if you can add the centerline, alignment, station marks, and text. And that's yes, you can do that. Maybe in the second session, I can show how you could add an alignment file to this. So Veta supports KMZ files and land XML files. The latter of those is what we recommend. So if you had a land XML alignment file, you could bring that in. If it had stationing, that would display as well. So we'll look at that when we get into some filtering later. Now, the next question I have is, can this data be seen live? And at this time, no. So this right now is kind of a post-processing. The best you could do would be to download data during the day and upload it here and kind of see where you're at so far. But at this time, this is not like a live view of the data. This is more of a post-processing tool. In the future, we are going to move to a web-based version. And as vendors kind of have like an auto, data beam to the cloud, it'll be easier and easier to see this in kind of like a near real time. But right now, it's really kind of more just like post-processing. So you would get your data that you've collected up to a point, and then you would put it in here. So great questions. Definitely keep them coming. If I didn't answer any of those, you can kind of let me know. So one thing too is you may be working on, several different projects in a season. So you may say, well, hey, I don't want to have to go customize all my legends, every single time I switch projects. So you can save these legends. So what we can do is come over here and click this project folder. So click on project and then go down and click on legends. So project legends. And we're going to have a few different options here. One is to save as default. So maybe, you really only have one project, or for the most part, the legends that you make, you pretty much want to be your standard legends. You could click the save as default. And then every time you open up Veta, the legends that you created will be shown. You can also save to file. So this is where it can be nice. If you have a few different projects going on, you can click save to file, and then it'll ask you to navigate where you want to save it, and it's automatically going to name it for you. Or of course, you can customize that name. I'm going to leave it as is and just click save. So now I have a file with this customized legend that I've just saved to that example folder. You can also go back to your Veta defaults. So remember, originally our pass count was 1 through 8. That was the Veta default legend. So if you ever want to just get back to that Veta default, you could come in here and click that button. or you could reset to your defaults that you had saved previously. So if I click Save to Default, I would show passes of 3. If I changed my legend and wanted to get back to this, I could reset to my defaults. So let's go ahead and take a look at how you would import that legend file we just created. So click the button that says Use Veta Defaults, and it's going to warn you, do you really want to do this? We're going to click Yes, and then hit Close. So you can see now we're back to these Veta defaults. So I'm going to import that legend we just saved. So let's click on Project, go back to Legends, Project Legends, and then click Import. So you should have this file that we saved. It should automatically take you there. I saved mine in the 5th example folder where we've been working out of. So you can just click the legend and click Open. It'll give us another warning, making sure we really want to replace the legends. We'll click OK. And then once we hit Close, you can see that our customized legends were brought in. All right, any questions so far on legends, viewing, anything like that? There's a couple more viewing features I'm going to show you here, but I just want to make sure we're not going too fast. I haven't lost anyone. All right, let's keep going then. So let's go back and click on Map again. So above your map tool, or on your map toolbar, the other thing on here that we didn't talk about yet is in the bottom half here, there's some different map options. So right now we're just using a road map, but we can click on this aerial map. And that can be really nice. And that's just going to give us, like satellite imagery. So a lot of times I will come in and set this up to where I'm just using an aerial map right away because I kind of tend to like that a little bit more, gives a little bit more detail. All right. I think that pretty much covers a lot of the viewing features. A couple other tools here above your legend. You have an option, it's this 2 pieces of paper, and it says copy map to clipboard. So if you click that, it's going to copy this map to your clipboard, and then you can go paste it somewhere else. So if you were working on some sort of report and you wanted to just easily copy this over without having to get, a screenshot tool or something like that, you can just click this button. And then you can also save the map to a file. So if you just wanted to save this, you would use that button there. Now, one other tool that can be really handy, especially for any sort of troubleshooting, is if you zoom in all the way on your data, you can right-click anywhere on your data. So let's do that. I'm going to just go over here and put my cursor where I'm on my data and right-click. And there's this little box that's going to come up that says Search. So you can click on that, and it's going to bring up the search box. And it's going to, first of all, it's going to give us the coordinate from where we clicked. So this is that exact coordinate of where my cursor clicked. And then there's an option to change your radius. So basically what this is saying is, okay, from where you clicked at this location, whatever radius you type in here, Veta will display all of the data from that point within that radius. So I'm going to leave it as a default of 0.3 meters. And then I'm going to click Search. So what Veta's done now is it said, okay, from that location where I clicked, or I could actually manually type in a location if I wanted, within 0.3 meters of that point, here's all of the data in the area. So this is what your data looks like, or what your IC data looks like. You've got a file name, you've got a timestamp. You know, depending on your vendor, you know, you're going to have kind of some different things here. You've got your location, you've got the direction where your roller was going, whether it was a vibratory or static, frequency, pass count. So basically just all of the data will be pulled up in a tabular format here. So you can see some different tabs across the top here. So one is all passes. That's the one we're looking at. So this is going to bring in all of the passes, or all of the data from all the passes. So you can see we've got 1, 2, and 3. Now note that there's an option to use your filter group or not use your filter group. We'll talk more about filter groups in the next session. So don't worry about that too much right now. Now you've also got something that says compact or final coverage. So again, final coverage is going to be referring to that final surface. So this is showing, you know, the very last pass, or the very last thing that a roller did. So you can see here, the last pass was 3, and this is the data from that very final surface. Okay, the next tool we have is this thing called heat loss. So what this is showing is within that radius you selected, it'll give you your average temperatures over time. So in this case, our curve is drawn a little bit wonky here, just because we've only got 3 passes. So we've only got, you know, 3 data points here. But if you're looking at a lot of different rollers, you know, you'll get a really detailed, basically, heat loss curve here. And this is a really great quality control tool, because you can come in and say, okay, you know, are my rollers being stretched too thin? You know, if there's a lot of time, you know, passing between these points, you know, maybe your rolling patterns, you know, stretched too far. You can kind of see like, hey, depending on what mix and what binder you're using, you can say like, you know, these temperatures definitely aren't where they need to be, or they are where they need to be. There's also tools available. If any of you guys are, you know, contractors, have done quality control in the past, you may be familiar with tools like Heat Cool. So what that looks like is it's a tool that you can plug in, you know, your project location, your mix parameters, what base you're paving on, your temperature information, and it will basically tell you a prediction of like how long your compaction window is, or how long you're able to pave for. So you can kind of have an idea of where you should be, and then you can use this as a tool to see if you're meeting that. Now, if you did have a project that had, you know, both intelligent compaction and added in the paver mounted thermal profiling, the temperatures from that would be posted here as well. So we have some data files in the example folder, which I will just show you real quick. If you're interested ever at looking at some combined, where you've got your paver mounted thermal profiling and IC data, we do have a couple example files here where you can add both to the project. And then you'd be able to see, you know, how you can kind of add multiple data types in one project, and it just kind of, you know, becomes more and more useful quality assurance tool. And I think that is a good stopping point for the morning session. So pretty much all we've really done is kind of gone through like all the ways to view the data. And then we're going to talk a little bit about filtering and then an analysis. And so in our next hands-on section, we'll kind of go through and we'll do some filtering, adding of spot tests, and running the analysis. But I think, George, I'm going to pass it back to you, and we can go through our next session, unless there's any questions of anything we've covered so far.
Sounds good. Thanks, Amanda. Today's workshop is 2 hours. So we'll finish the first hour about 66 minutes instead of 55. So if nobody objects, we're going to continue with session 2. And we'll complete by the noon time, Central Time, US Central Time. So I'm going to share my screen here. So the section 2 is talk about how the data can be processed. But first thing first. So what is IC data? What has been collected and how it been processed? So for all IC system, different vendors do the similar things. This is showing the roller been rolling within a short section. And typically within each 1 feet of distance, it will record one set of data. What I mean, one set of data that include roller position data, temperature data, if any, ICMV data or stiffness data, frequency, amplitude. Basically, you can see the dropping of the circle on the top row here is the raw, so-called ungraded data. And most of the map you're seeing from the IC vendors display is the bottom, which is the process, or so-called gridded. They were gridded and duplicate the one circle data across the drum, typically by 1 foot by 1 foot grid. We're going to show you every vendor has slightly different grid size. So the data you're seeing been color coded on the map, including the one on the IC vendor's display, or when after you bring it to Veta and plot it, those are the gridded data. So depending on what the vendor has supplied, Veta can take either the raw ungraded data and then grid it within Veta, or they can take the gridded data and showing what already been gridded by the vendors. For a recent practices that some contractor may use a mixed fleet of different IC vendors' data. And to combine them is very difficult unless they are ungraded data. So after the data have been graded, the data will be sorted and start being counted by the software in Veta. In this case, if graded, then the pass count will be counted. In this case, there are 4 grids on the bottom that have pass 1 roller, have passed over, and then you can see on the second layer, it passed over again on the 4 grid. Then the third passes have missed the top 2 grid and only covered the 2 bottom grid. So this is what we call the all passes data in Veta. It includes all the data in so-called the compaction history data, include everything. And then I also show you the viewer screen that you can select the final coverage data, this so-called the bird's eye view, by looking from the top down. In this case, you only see the final product with the final result of 4 grid with 2 grid with 3 passes and another 2 grids with 2 passes. So it's very straightforward. As I mentioned, every vendor provided slightly different data format. They're all compatible with Veta. And also, depending on what kind of data format they use, vendor may provide multiple formats from their different system or from the same system. It's just different option to export the data and to be able to use in Veta. And you can see from the table, first table here, there are 3 vendors, including Bomag, Caterpillar, Trimble, and Leica provided the graded data. Actually, Leica is graded data only. So this need to be corrected. And the grid size is slightly different. Most being used 0.3 meter or 1 foot by 1 foot. And the Caterpillar is slightly different. And Caterpillar Dynapipe been using a 0.4 by 0.4 grid. And on this page, Caterpillar Trimble allow the direct download in a TDS format, which is in binary. That's the Usher standard MP39. There's another set of vendor. In this case, MOBA, Topcon, Vocal, and Volvo, they all have the option to provide ungraded data. And MOBA, Topcon have provide option for direct download. We're currently working with other vendors to make the data to be downloadable directly from the cloud as we speak. So one of them is Hum. We're working with Hum to make the data direct download from the cloud, probably in the remaining of the year. So this is what I mentioned, the file format of intelligent construction data published by Usher. So we helped to develop this standard that will cover the different technologies. Currently is including the data from the intelligent compaction technology, but also paver-mounted thermal profiler technology, which Amanda will cover the workshop later on. And another technology, so-called the dielectric profiling system that Amanda mentioned. That's the so-called the rolling density meter or similar that will measure the dielectric constant of the in-place asphalt after the compaction. And that dielectric constant can be correlated to the air void or density of the asphalt. So Veta is a standard platform that supports all the three technologies that I mentioned about, and also the more technology in the future. One such technology that we're including this year, which will be available in early 2024, is e-ticketing data and other associated data. And the Usher have standardized it, to call it Material Delivery Management System, MDMS. So in the Usher R111 standard is intelligent compaction standard, as it requires Veta to be the standard platform for data processing. That I mentioned earlier, there's a graded data, all processed data, and also raw ungraded data can be imported to Veta. And for data to go all the way from the machine to Veta, it can be using a local file, as Amanda has shown you in her first example. And the local file can be either exported from the machine directly or from the software, vendor software. A direct download is actually happening already for several vendors I mentioned in the table earlier. That is preferred methods to transfer the data wireless telematically to the vendor's cloud. Then the user can download directly to Veta. There's one question about whether the Veta data is live. Is not live. It's near live if you have a direct download from the cloud and you can refresh it at a regular basis. In 2024, we're planning to develop web-based Veta that will allow more timely data transmission or viewing from the machine to the cloud. So Amanda has shown you the more updated version of this data download from the cloud. They include Mobile's IC data, Topcon's IC data, Trimble and Caterpillar IC data, and also Volker's PMTP data. And Amanda has shown you for the first example that once you import it to the data to Veta, always double check the data import wizard with the map viewer on the right, make sure the data been imported correctly. Also on the left-hand side, the Veta will report how many data points have been found and how many data points have been added or successfully imported to Veta. It's not always 100%. If there's erroneous data, it won't be imported, such as the GPS data being incorrect. If you imported several data files to Veta, there's a facility called editor to manage and view all the different data being corrected. They will track when the data being imported, how many data being found, whether there's any invalid coordinate, successfully imported data points. And for now, the data that be imported from the same technology cannot be overlapped. If there's any duplicate, and Veta only going to keep one copy. Amanda already showed you to review the data side by side, and Veta they can switch to different data type from the IC data, and it's very useful to view the pass count and the ICMV data or the pass count versus temperature data. It's just very, very powerful visualization, visual inspection tool. Important alignment file. We can Veta can import alignment file in different format, including KMZ file and land XML file. And land XML file is preferred because it includes formula for the alignment file, and its vector rise of file is more correct, more precise, and also include the station that can be used for later use, such as create a boundary. That's what I'm talking about. Land XML file is the more preferred. You can see the example I have shown on the top table. Once it imported, it will show the different region or direction of the increasing station number, and also the location and so on. But it will depend on whether the DOT project have the design file or whether they have the capability to export it to the land XML file. Filtering data is what Amanda have left off at the end of hands-on first sessions. Filtering data is very important, and to filter out the unwanted data and only include the data that you want to be used for the analysis. So they include a very sophisticated tool. It's called filtering group that include data filter, operation filter, and override filter. Amanda going to show you in the next example how to use the basic filtering. Spot test data is one we mentioned for the first session, that you collect the spot test data, organize into a spreadsheet, then you can copy and paste into the spot test facility in Veta. And this show one example data actually from the Indiana example that show the black dot on the bottom of those spot test data. And analysis, a lot of options. I'm going to go through more in detail in the second hands-on exercise, that you can include different kind of data for analysis, and also include the data to be analyzed, and also the different analysis option to analyze the sublot or not. And this is one example for rural coverage with a pie chart. It's very good, easy to understand visualization presentation. Okay. Every data analysis, it also includes a statistical analysis, show you the histogram, accumulated specific distribution. Veta also include correlation analysis if you do have spot test data and you will correlate to the IC data. In this case, is density versus CCV or compaction control value from Sakai. That's one thing called compaction curve. In this case, is the average value for the stiffness data for each passes. You can see the pass 1 all the way to pass 7 have an increase and then have a decrease. This is compaction curve to show the trend or for the stiffness data. In this case, after 5 passes, it's over compacted and start to go down. One very important feature in Veta, hopefully Amanda will show you today, is the so-called using the quality control chart to show the quality control chart of selected metrics. In this case, mean pass count or mean temperature for versus distance or sublot to help you to monitor if any changes in your paving process. All right, so I'll pass back to Amanda to give you another about 40 minutes of hands-on exercise.
All right, and I just responded to a question in the chat, but I just realized I answered the wrong question. So maybe Subu, you can fix that for me. But the question was if we could add an alignment file. So we're going to go through and see if we have time to do that. But if not, I did put the example number that uses a land XML file. So it's actually example 6. So if we run out of time, or if we go through it and you need a refresher on it later, example 6 is going to be the one that you want to look at. All right. So you should be seeing my screen again. So I just have our project from where we left off. So we're going to just kind of continue working on this same project. So one thing I wanted to point out is this data files screen. So George just showed this one. So this is where you can kind of see all your different files and some of the import information. So if you start adding lots of files, this can be a really useful screen to kind of come in and see, oh, here's all my files, and kind of get this information on your data here. We're going to skip over the alignment map for now, and we're going to go straight to this filters map. So click on the icon that has the blue funnel. It says filters. So this is really sort of, the heart of Veta, is being able to really get in and filter and clean up your data so that whatever you're analyzing is an accurate representation of your project. So we're going to be working on this filter screen for a while, but, one thing I just kind of want to point out is, just looking at our data set here, you can see kind of at the beginning here where maybe the roller was parked, and we've got this data where the roller was just getting started. That doesn't necessarily reflect our project, right? So if this is just mobilizing to get started, that doesn't really reflect the project. If we leave this in here, it's going to misrepresent the project as having, some percentage where there was only one pass, which would not be good. So filtering is really important. So we're going to kind of go through that now. So what George mentioned earlier is, the first thing that you always want to do when you're creating filters is you have to have a place to put the filters. And that is going to be in your filter group. So this can be something that takes a minute to kind of really fully understand and comprehend. But I promise as you go through, more and more Veta examples, it'll really start to make sense. So first step, just remember, first step always, when you come to this filters tab, you're always going to start right here with the manage groups button. So it's the same blue funnel, but it has a little pencil next to it. So go ahead and click that. And it's going to bring up the filter group manager. Now you're going to see some stuff on here like the filter naming template and folder and, center line offset data log. You're going to see a lot of extra things on here, which we do not have time to cover today. There is a AASHTO standard naming convention for how you set up your filter names. It's definitely a more advanced topic, and we're not going to get into it today. So all I want you to know is a lot of some of this extra stuff you're going to see on here is associated with this AASHTO template. But we're not going to use it today. And you really don't need to use it unless you're wanting to implement that AASHTO standard. So what we're going to do is we're just going to leave everything default. And the only thing we're going to use on here is this filter group name. And we're just going to name our filter group. So to keep it simple, I'm going to name my filter group just to match the project. In terms of data management, I do recommend that you come up with some standard naming convention. Usually it's helpful to put like a project number and a date. Like those two things usually are really important, just to kind of help, keep everything sorted. If you had, certain lift you wanted to keep track of, you'd want to maybe put that in there. But for now, we're just going to use this 05 ICIN HMA. So I typed that in, and then I'm going to click this add button. So I click add, and then it gets grayed out, and it doesn't look like anything happened. But if I click this arrow next to miscellaneous, I can see that now this filter group that I've added has been created in that miscellaneous folder. So I have two things now. I have empty group, and I have the filter group I just created. So empty group is going to be your raw data. So no matter what you do here in the filters, you can always go back to your raw data by going back to your empty group filter group. Okay, and then the one that we just created, we're going to add some filters to this, and then that's going to be our filtered data. And so we can toggle between the two at any time, between our filtered data and our raw data. So make sure that you have clicked this arrow next to miscellaneous, make sure that the filter group you created is there, and then go ahead and click OK. Now up top, you'll see we have this filter group box, and there's a drop-down menu next to group, and the one that we just created is displayed. And if you click that drop-down arrow, you'll see you could always go back to empty group. And again, that's going to bring back your raw data. Now, as you get more advanced in Veta, you may start having, multiple filter groups. If you put several days worth of data into one project, you could have a filter group for each day. There's a ton of different ways to set up filters. And it's all going to be kind of project dependent, and depending on what you're trying to do, or what the state wants you to do, anything like that. So lots of different ways to do it, but you'd always be able to access any of your filter groups using this drop-down menu. There's another box up here that says override. That's another pretty advanced topic. We're not going to talk about override filters today, so don't worry about that. That's kind of something for definitely a more advanced class. So now let's go over on the left and take a look at our options here. We've got something that's called calibration functions. That is specific to DPS equipment, so the dielectric profiling equipment, or as some people know it, the rolling density meter. So since this is an intelligent compaction project, this is not going to apply to us here. And then I've already mentioned we are not going to talk about override filters. So we're not going to worry about that. And so we're just going to be focusing on data filters and operation filters. So let's go ahead and create an operation filter. So to do that, you'll come over on the left and you'll just right click where it says create operation filter, and then click create operation filter. And the first thing it's going to do is it's going to prompt us to name it. And I'm just going to stick with the same naming convention. And I'm just going to name it to match my project and my filter group. So 05-IC-IN-HMA. So go ahead and type that in. And then this is important. After you name your filter group, just make sure to hit enter. If you type it in and then just like click somewhere else, it won't save it. If that ever happens to you, you can always right click and click rename and then type in a new name and hit enter. So I'm going to check the box next to it. And when I do that, what I'm saying is, okay, put this filter in the filter group that's displayed right now. So I can make multiple operation filters, and I can choose to put it in this filter group or not put it in the filter group by checking and unchecking that box. Now, if some of these concepts and topics seem a little complex, no worries, you're not alone. This is definitely one of the more kind of difficult parts of Veta. And the reason being is because there's just a lot of options. It's a very powerful tool. And so it just takes a minute to kind of really let it sink in and understand what we're doing. But I promise as you go through a few examples, it'll really start making a lot of sense. All right, so let's talk about common and compactor and why we have those two categories. So for common, what that's saying is any data that's in the project, anything I do under common, it will apply to everything. So again, if I have IC data and thermal profiling data, or DPS data or a combination of all three, anything I put under common is going to be applied to all three data types. Now, anything I put under compactor, that's only going to apply to my IC data. If I did have thermal profiling data in here, I'd have another category specific to that equipment type. So common applies to everything, or we can have equipment specific under the equipment name. So one thing that George has mentioned a few times is that boundary data. So we've got a lot of you guys asking about alignment files. So an alignment file is one way that you can sort by location. So again, if we have time, we'll take a look at that. The other way is just using coordinates that have been collected. So if we're out paving for a day and you can go and collect the boundary of what you've paved, just the different coordinates, you can actually just cut and paste those directly in, and Veta will remove any data that falls outside of that. And so that's what we're going to look at right now. So we're going to go ahead and put it under our common. Now, since we only have one data type in here, whether we put it under compactor or common is really not going to make a difference. But it's kind of best practice for location boundaries or boundaries that you would normally want to apply to everything. It's kind of good to just put it under common. So that's what we're going to do. But if you look, you'll notice we have location under common and compactor. So again, it doesn't really matter in this case where we only have one file. But we'll go ahead and just kind of do best practices. So if you click under common on location, you're going to have this little dialog pop up over here on the left. So common, location, and then you're going to click source. So there's different options to filter by location. The one we are going to use right now is custom. So go ahead and make sure custom is selected and then click OK. And then we're going to have this little empty box that pops up with northing and easting. So go back to your file explorer and find the sample files on your desktop and go back into example 5. And you can see that we have an Excel file in there that's called boundary coordinate. Go ahead and open that in Excel. So we're in example 5 and we're going to open boundary coordinate. So George mentioned too, what's important is that these form a loop around the data. So basically they just need to be sorted so that they form, a loop or whatever kind of shape you want to call it, but it's got to be in the clockwise or counterclockwise direction, just kind of encompassing the data. So if you're collecting these out in the field with a handheld rover and a data collector, you may not be collecting them in a loop, but just make sure that you're able to sort them later so that they form a loop. So what we're going to do is we're going to highlight everything in yellow. And one important thing is you want to make sure to get the northing and easting headers in there. Just want to highlight everything. And then you can either hit Control C or you can right click and hit copy. So all we've done here is just copied it to the clipboard. So again, these coordinates were collected using a handheld rover in the field. And then we can go back to Veta and we can right click anywhere in the box. And each of those little coordinates is going to get pasted, and then Veta is going to draw a boundary around it. So the boundary is going to show up as that little blue line, and you can see it's going to cut off some of my data that I don't want in there. So you have this little warning that comes up and says apply filter group to refresh map. All it's saying is, hey, you've put a filter in here, but you haven't actually applied it yet. So to apply it, you're going to hit this yellow apply flag up at the top. So it's in the filter group box. It's active. So when you have this warning, this is going to be active, meaning it's yellow. So let's push that. Our little warning goes away, and now this is inactive. So we know that it's been applied. So now we can kind of scroll over and we can see that some of that data that we didn't want to include in there has been removed. Now there's a lot of other ways to filter data. The location filters generally, like one of the important ones. You can also filter by timestamp. So if you want to break out your data by time, you can do timestamps. You can look at different machine IDs. So if you had multiple rollers and you only wanted to look at one roller, you could come in here and just select which roller you wanted to look at. In this case, we don't have separate machine IDs in this file. Now there's also a bunch of filters called data filters. So let's take a look at some of those. So to create a data filter, you'll just right click over here where it says data filter. And then it should pop up and say, create data filter. You'll click that. Again, I'm just going to name mine the same thing I've been doing. Hit enter. And then you'll check the box. And then you can come through here and you can kind of just see different options for filtering. We won't get too into them, but what I recommend is just, kind of coming through and playing through all these filters and kind of just seeing what they do to change the data. So obviously one that's really nice is this compaction mode. So if your vendor, reports whether it's vibratory or static, you can actually come in and filter by that. So it can be really useful if you only care about your vibratory passes. You don't want to look at the extra static passes. You can come in here and you can just click on vibratory. So you uncheck use all and you would just check vibratory, and then you could filter that way. So I'm going to go and leave it as use all for now, but just know that there's lots of different options and ways to do it. And some of the other example files will kind of walk you through some of the different filter types as well. All right, let's go ahead and move on. We're going to look at our spot test screen next. So this is where, if you're taking core data or nuclear density readings, or, if you're on a soils project, it's LWD, you can kind of just come through here. You can add the results to those along with the location, and they will plot them in here. And then correlate your spot test results to your intelligent compaction data. So let's go ahead and do that. You can do it manually. You can come up here and use this add button, and then you can just type everything in manually. But it's a lot more efficient to go ahead and just copy it from a spreadsheet. So let's go back to Files Explorer and go back to your example folder. Make sure you're in example 5, and then look for the other spreadsheet in there. It's called Indiana Spot Test TB04. So go ahead and open that spreadsheet up next. So these are spot test data on different passes. So let's go ahead and do the same thing. Anything in yellow, go ahead and just select it. And make sure you get the headers in there. Now, Veta is really particular about your headers. So just make sure you use like this format here if you're going into copy and paste spot tests. But select everything in yellow and then right click and copy or hit Control C. And then we can go back to Veta. And then you have some different tabs up here. Since we have different passes associated with each of these spot tests, you can see we have like pass 1, 2, and 3. So since they're specific to each pass, we want to put them on the individual passes tab. So make sure that the tab you're on up here says compactor individual passes. And then anywhere in this box, you can just right click and hit paste. And then you can kind of zoom in, and then it's going to show you all these spot tests. And if you hover your cursor over them, it actually has tooltips where it'll tell you, the value for each of them. You kind of just take a look. This is another time where it might be nice, if you wanted to come in and hover over one of your spot tests, you could right click and hit search and click search again, and then it would bring in the data, right around that spot test, and you could do kind of get an idea of what the data looks like right around that test. All right, so now we have some spot tests added in here. Let's go ahead and run an analysis. So let's go to the analysis tab. So it's right next to spot test that has a little chart on it. So just like the filtering screen, there's going to be a lot of different options to run the different analyses. So filter review, we're not going to worry about that. And then anytime in Veta you have these little arrows, you can always expand or minimize them by clicking them. So if you click on setup, we're going to leave this as defaulted. So all this is saying is we want to analyze our IC data and we want to use our filter group that we've made, and that's selected. And then let's click on compactor. So let's go ahead and click the tab that says individual passes. So what that's saying is, give me my final coverage analysis, which again is that final surface, but also show me, the individual pass data. So also like run the analysis on each individual pass and give me those results as well. And then we're also going to check the box next to analyze sublots. And we're not going to worry about semi-variogram. Again, that's kind of more of an advanced topic. Now note that you have analyze sublots checked, and then you have something up here that says sublot length. So that is customizable. So we're going to leave it as the default, but you can come in and customize what length you want Veta to break your sublots into. And all we're saying basically is, take my data and then break it into smaller chunks of this length and analyze it so that we can kind of get an idea. Now, we don't have a huge amount of data, so this isn't going to be very useful for us in this case, but if you had, a full day, using sublots is a good way to kind of find isolated areas that may need some troubleshooting. Okay, there's different specifications we can set as well. So if you have like a target CCV value, which again, this is going to be that accelerometer-based measurement, you can set the target values in here. So one thing to note, we haven't really looked at the example file in here very much, but again, each of these example files have a PDF instruction file. So if you open this one that's in the 5th example, we're here at step 5, setting up our analysis. And so it does give us a target CCV value for this project. So let's go ahead and use it. So it's saying the CCV target is 12. So we're going to set our minimum greater than 12 at an acceptance rate of 70. So to do that, click CCV, and next to minimum, click the drop-down box, and let's do greater than or equal to. And let's type in 12. And as we're typing this, it's going to fill this little statement up. So if we type in an acceptance percentage, so let's type in 70, it'll tell us what we're setting. So we're saying 70% of data should be greater than or equal to 12. So you can do that for any data type. So let's go ahead and set one for pass count as well. We know that we want to have a pass count of 3 on this project. So let's set the minimum greater than or equal to 3. And let's shoot for 90%. Now we could put a maximum on there as well if we wanted to and say, maybe we don't want to get too many passes either. But in this case, let's just say at least 3 passes. All right, now if your apply flag over here is active, go ahead and just click on it. We'll make sure that whatever we've done has been applied. And then we're going to click Analyze. So as we do that, we're going to see results popping up over here. And again, one of the best ways to really kind of understand all of these analysis options is really just to go through, click through all of them. As you're kind of going through other example files, you can just start looking at all of the different results, and you'll kind of start seeing like what's useful to you as a quality assurance tool. So one of the really good ones is this coverage tab. So if you click on coverage, this is going to show you your pass count coverage. So you can see that 74% of the project had at least 3 passes. So I would say that's, that's good, not great. Like I think we could do better. And then this is, of course, a tool that you could take back to your roller operators and say, hey, we're trying to get 3 passes on everything. We're only at 74. Like I'd really like to see that above 90. And then, that's just a tool you can take and really try to improve that and get some more consistency in your roller coverage. Now, one thing to note is the legend for this pie chart. It does match the legend you set here. So that's why it's always a good idea to kind of customize these legends to be, project specific and match the pass that you're trying to target. So coverage, super great tool, super great result, super easy to just come in and look at that and know right off the bat how uniform your roller operators are covering the area. Now you can click the arrow next to overall results and we can kind of click through. This is going to be similar to that coverage chart, but just kind of give you a distribution of the passes. The difference between this and coverage is that coverage is going to consider that boundary you put in, and this is not. Now you can see we've got a drop-down menu over here where we can look at final coverage or all passes. So again, final coverage being that final surface. And you can kind of just click through and look at the distribution of all the data types. One thing with temperature, again, if you wanted to, you could use this drop down and you can come look at individual passes as well. So since we checked that box on the analysis screen that said analyze individual passes, that gives us the chance to come through and look at individual pass results for everything as well. So again, pass 1, that's going to be your very first breakdown temperature, which is going to be useful to kind of come in and look at. Okay, we have another tab over here that says correlation. So this is going to be correlation between your spot test data. So right here, we're not looking at a very good correlation between temperature and density, which, you know, maybe we wouldn't necessarily expect in this case. But if you come down and look at the CCV, this again is going to be the stiffness data. You can kind of come through and look at how your spot tests correlate to that stiffness measurement. So again, in the drop-down menu, you'll want to either select all passes or pass 1, 2, or 3. Let's look at all passes for now. So make sure your drop-down says all passes and then click this correlation tab. And this is going to show you how those spot test density results correspond to your density. So not a perfect correlation, but you can see like the trend generally shows that as your CCV goes up, so does your density. So that just kind of shows, you know, how you can kind of use that CCV data as a quality control tool as well. When you're out there, you know, if you notice, you know, an area that's really, really low, you know, you may have some issues in that area. And so you can kind of just run these correlation analyses and kind of just see how they compare. And then sublot results. So again, this is where it's just kind of taken our data and it's broken it into these little sections. So one of my favorite results is sublot results summary. This is going to give you pretty much a lot of information. It's going to show you your CCV versus your pass count. So this is how that stiffness is changing with different passes. It's going to give you the temperature cooling curve that we've looked at earlier, where this is actually giving you temperature over each pass, so you can kind of see how it's cooling. It's going to give you how much time is passing between passes, and then it's going to tabulate all this data for you as well. So you can kind of just click through each of the little sections here and take a look at sublots. Super useful tool. You can see here, since we set those specifications, it's going to tell us whether it passed or failed. So again, we're targeting a CCV of 12. It's going to show you each sublot where that was met. It's going to do the same thing for pass count. So it's going to show you each scenario where our pass count met 90% of the target, which was 3. And you can see it didn't pass here. We weren't quite at that 90%. Okay, the other kind of useful results, one that George showed earlier that's really nice, is this quality control tool. Normally, we'd also have an option for speed. For whatever reason, this data set doesn't have speed. But this is going to show you the average temperature for each sublot. And if it had speed, it would show you the average speed for each sublot. So another really useful tool, you know, if you guys are familiar with asphalt paving, you know, temperature and consistent speeds, like those are 2 really important metrics for quality control. So if you can come here and see that your temperatures are pretty consistent and that your speed is pretty consistent, that's a really good way, you know, to kind of see, hey, things are good. If they're not, if they're kind of all over the place, it's another tool you could kind of take to your roller operator and say, hey, you know, let's try to make our speed more consistent, or let's, you know, talk to the plant, figure out why our temperatures are all over the place. You know, it just kind of gives you that knowledge and tool to go make some corrections. And then again, you know, you can kind of come through and look really at anything, whether it's overall result or sublot result. And we only got a few minutes left, so we're not going to have time to add the alignment file. But again, just to point it out, if you look at example 6, you've got alignment files here and an instruction file. So if you go through example 6, it's going to tell you exactly how to add this land XML alignment file, and it's going to show you how you can filter out a boundary using the alignment file. So if you're interested, definitely go through example 6 here. And with that, we've got 3 minutes left. I'm going to open it up for questions, or open it up for George and Subu if I missed anything that they wanted me to show. Got a couple minutes yet.
Sounds good. 2 hours workshop is limited, but hopefully it can help you to get off the ground and get your feet wet with the Veta analysis. We just scratched the surface today with just some basic operation of Veta. But the best way to learn Veta is go through the sample set that we have given you, and each subfolder include a very detailed instruction in a PDF file. You can just paste yourself and follow the instruction and do the analysis yourself. And this workshop has been recorded, and I'll be sharing with you with the recording link we'll send you within a day. Any other questions you can put in a box, check box? Yeah, most of the question today from the chat box pod are regarding how to bring the data in. So bring the data in. If you're first-time users, make sure you communicate with your IC provider. Every vendor is different. Just make sure the technical support or dealer that you work with for the IC provider, work with them and learn from them how to set up the machine, how to collect the data, and how to download or export the data. As I mentioned, every vendor is different. The data can be stored, always stored in the machine first, and then pushed to the cloud, or it can be exported using the USB drive. So very important is to make sure you validate all your IC data at the beginning, such as your GPS, make sure it's all correct before you move on to the data collection. For most DOTs in the US, they require the data validation to be done on a daily basis. Sounds tedious, but once it's done, it's been done multiple times, it's very, very straightforward, very straightforward. It's just part of the data setup and warm up process to do data validation. Then you have peace of mind that your data collected are all correct. A lot of powerful tools that Amanda had touched on, such as this one showing the screen here, that you can view the data map along with the compaction curve and also data, the temperature drop curve, as well as the lapse time between the passes. Those are great quality control tool that you can look at for lot by lot basis, and that can help you to troubleshoot your paving process. So this will conclude our workshop today. Thank you for attending this workshop. We'll be sending you a follow-up email within a day. Thank you, and have a great day and a great night.
Thanks.